The next exercise is by using the Gauss's law, find the expression for electric field at point above the midpoint of infinite dimension sheet as shown in figure. Okay, and we have already done this exercise by definition of electric field intensity. Now we will try to find this expression by using the Gauss's law. So that is the difference. We have already done this exercise by using the by only finding the we already done this exercise by definition by using the definition of electric field intensity. Now we will use find the solution, find the expression by considering Gauss's law, okay, as the application of the Gauss's law, okay, and you will felt that that is a very simple and as compared to that, okay. So that will be the sum, okay. Sorry, these are the positive distributed, uniformly positive distributed charge. Here this is the for uniformly distributed charges, okay, and dimension of this sheet is infinite, okay. This is plane sheet. And dimension of this, the length and width of this sheet is infinite. Okay, so you may say that this is, if I considering this, so the infinite length. Okay, as if I see in the as we have done in minus infinity to plus infinity. Okay, so but now we will consider that for Gauss's law we have to consider the surface. In the previous exercise in definition of electric field we have there is no condition to consider the surface, but in the Gauss's law we have to consider the Gauss's surface. Okay, so for this purpose, since all the electric field line is this sheet is infinite dimension, so electric field will be okay, or both sides of the plane. Okay, E field will be upward and downward. Okay, okay, and since E field is above, so if we consider that now we have to consider the Gauss's surface. Okay, so we will consider that there is cylinder. Okay, this and this, okay, this area, let's suppose this is the area of the surface. Okay, let's suppose if this is solid cylinder, okay, and this is the area. Let this area is you may say that this is because this is circle, you may say that this is a pi r. If the radius of this is r, then the area will be pi r square. You may say that this area is pi r square if this r is the radius, okay, pi r square, okay, for both sides, okay, and pi r square. If I consider that this is r, okay, this length is r, if the radius of the circle is r, okay, got it? So according to Gauss's law, what is the Gauss's law? We have already explained that according to Gauss's law, the closed surface integral is equal to E dot the Gauss's surface, okay, E dot ds equal to q over epsilon naught, okay, yes. So please be sit down, okay. So this will be equal to this, okay. If these are the E's, okay, upward and downward, okay, these are the E, okay, okay, one is going upward, this, okay, yes. So there are three surfaces of the cylinder, two is this and one is rounds, okay. So if we say that this closed line integral, closed surface integral will make a three surface E dot ds S1 plus S2 E dot ds, S2 plus S3 E dot ds. Okay. Okay. So S1 is, these are the, this is S1, okay. This is S1, this is S2, and the round surface is S3. So there are three surfaces, okay. You may say that circular surface, okay, and this is a round surface, okay, and this is a Q over epsilon, okay, according to Gauss's law, okay. But what is the Q? Because charge is uniformly, because charge is uniformly distributed on plane sheet. This is given, okay. We have assumed that this the charge should be must be uniformly distributed. Yes, Usama. So if the charge is uniformly distributed on the sheet, okay. So then the Q will be because the sheet is plain. This sheet is plain. So this sheet will be the charge will be distributed uniformly as a surface density. Yes, and surface density is represented by sigma. Okay, charge per unit, and this will be sorry. This area will be, this will be that surface because we are considering the this cylinder, okay. So the charge bound by this surface will be equal to okay, charge is distributed in the, yes, and this will be dA, and this will be equal to, and this the if this is R, this length will be also R, okay. If this radius of this cylinder is R, then the radius of this circle will be also R. So the area will be, and then since this is uniformly distributed, so this will be as dA, and this will be pi R square. Okay. Yes. Okay. So this will be a sigma pi R square charge enclosed by Gauss's surface, because we are considering the charge enclosed by the Gauss's surface. Okay, that's why we are considering the, you must understand, that's why this will be equal to this. Yes, Asama? Okay. Please switch off your mobile. Okay, so this will be equal to this. Okay, so by putting, okay, so putting all these things, S1 is the circular surface, so radial E is R, outwardly radial, okay. The angle between, if this is S1, the angle between S1 surface and E will be, what will be the angle? This is E, and surface. This is, okay. This area of the surface. This will be a direction of n unit vector, and this the surface direction will be upward, downward. E will be also downward. Here the n unit vector will upward, because area always representing. If you are considering the outward, this is down. This is also outward surface. This is outward surface. If you are considering the surface as the outward positive, then you have to consider all surfaces outward, because you are considering the outward surface, that is n is positive and E is also positive. So angle will be between E and S1 will be 0. So you will get S1 E ds cos 0, okay, plus S2 E ds cos 0, and the area is always the area of round is always radial. It will be outward radial, okay, tangent to this, always tangent to the circular surface, okay. So that will be make a angle S3, that will be E ds cos. What will be the angle? Because this is like this this is cylinder, okay, and the all at all sides the area is this like this, okay. So that will be always the outward. So area will be always. Unfortunately, I forgotten the red marker in my room office. So that will be like a mean n unit vector, and that will be always sorry, I should make use of two markers. This is a cylinder, okay, and all these are making angle 90 with, okay. So the angle is 90 because it is radial, okay. So that will be angle will be a 90, okay. Got it? Why angle between round the direction, why the direction of a round surface will always tangent to its surface and will be radial. So angle between round surface and E will be pi radian, or 90 degree, okay. That's why that will be a 90 degree or radian, okay. Got it? So you may easily observe why that is equal to 90. Okay, Asama, have you got it? Okay, so that's why this, that is 90, and this equal to and the right hand side, the Q is, I have already explained, the Q is sigma pi r square over epsilon naught. The direction of the round surface will be always tangent to its surface and will be radial. Okay, so angle between round surface and electric field E will be pi, say pi radian or 90 degree. Okay, pi radian, sorry, pi by 2 radian, sorry, I have gone, okay, you are pi by 2 radian, okay, or 90 degree. That's I want to say, okay, pi by 2, not pi. Okay, that is the orthogonal, okay, at every way. Okay, got it. So if it is orthogonal, then what will be, so what will be the result? If cos 0 is 1, and we know that since E is uniform, please, E is uniform, kindly please. E is uniform, so E will be, जब uniform होता है E का same है, same mean integration will be not applied on this. So E ds s1 plus E ds, sorry, s2 plus cos 90 is 0 plus 0, that is equal to sigma pi r square, sigma pi r square over epsilon naught. Okay, that is a very simple. Okay, so what is the area pi? We have already explained, that is will be a pi r square plus E, because radius is same, E pi r square equal to sigma pi r square over epsilon naught. Okay, and you may write as a 2E pi r square is equal to sigma pi r square over epsilon naught. Okay, so pi r square will be cancelled out with this. Okay, and so you will get the, what is the result? So this implies that what will be E? Yes, E will be equal to sigma over 2 epsilon naught. So this will be result, and I think that is result is the same as we have gotten by a lengthy calculation, but in this by using this law we have done by use very few steps. Okay, this is the result. Okay, and this since E, and if we consider the direction now that all E's are along the this, so we may say that E vector is equal to sigma 2 by epsilon naught or unit vector. Okay, that's the distance. R is the length. Okay, so that will be okay. So this will be the same result what you have gotten by very lengthy calculation, but using the definition of electric field intensity. But this is, I think, there is a very few steps. And always remember that this electric field is if you see, if you may easily observe that the R unit vector is using the direction, as a direction. So the you may easily observe that magnitude of electric field intensity is not depending upon the distance of the point. If P is near away from it is not depending upon the distance of point from the sheet. Okay, because there is no R is involved here. Okay. So what is the result if you are interested to write? What is the result? They are so if I interested to write the result and summarize, what is the result? Number one, E is equal to sigma by 2 over epsilon naught, mean constant, one, and second, electric field intensity due to plane sheet will be due to charge distributed on plane sheet will be independent from distance of point from sheet. So you got two results. Okay, and this result is the same as we have derived by using the definition of electric field, but in a very simple way. But that was a very complicated and lengthy calculation. Okay, so I think this is